Hey there, and welcome to exercise number 61. In this one, we need to write a function named getPaginatedData that is used to get a certain page from a sorted array of items. Now, the function should receive 5 parameters. The first one is an array of objects representing users, each with the following properties: ID, name, and age. ID and name are both strings, and the age is of course a number. Now, the second parameter is called sortBy, and is the name of a property inside the user object. So it's either ID, name, or age. Moving on to the third parameter, we have a string representing the direction in which we want to sort the user's array. This parameter has only 2 values. It's either ascending, so in that case we have the string ASC, or it's descending, in which case we have this string. Moving on, we have the fourth parameter, which is a number representing the number of items we want to have per page. And this one is going to be called perPage. And finally, we have the page number we want to receive, starting from index 1, and this one is called page number. Now, the function should return a new array of objects representing the users that are on the requested page, and of course, in the correct order. So basically, we have an array of users and we say, okay, I want to sort them by this property. I want them to split them into pages, and then I want to get this page. Below we have an example. So if our users array is this one, and we want to sort by age, descending, and we want 2 items per page, and we want page number 3, we should get user 5. And let's actually verify. So if we sort by age descending, then it's going to be, the order is going to be user 4, then user 2, then user 1, then user 3, then user 5. Okay, we want to have 2 items per page, and we want to have page number 3. So this is the last page. We have 5 users here. So actually, let's move here on the right side to verify this. So the order, if we sorted by age descending, is going to be user 4, then user 2, then user 1, then user 3, user 5. Then we split them in pages of 2. So we get those 2 are in a page. Let's put this one. And then those 2 are in a page. And then we want page number 3. So this page number 1, page number 2, and this page number 3. So the answer is an array with just 1 user, and that's user number 5. I'm going to go here into the right side, into the code area. And the first thing I want to do is sort the users according to the sortBy property and the direction. Now, I want to create a new variable in which I have the sorted users, because the sort property on array modifies the array, and I don't want to do that. So let's create a sorted users is, and I'm going to spread the users just to duplicate the array users.sort. And here we get user 1, user 2. And we basically have 3 scenarios: if sortBy is ID, is name, or is age. And let's actually start with age, because that makes, I think that's the simplest one. So if sortBy is age, and here then we have 2 more situations: direction is ascending or descending. So I can do it like this. If direction is ascending, I want to return user1.age minus user2.age. Otherwise, I want to return the reverse, right? user2.age minus user1.age. Now, I have here an if and then another if inside, which is a bit harder to read in my opinion. So I just want to use a ternary here. So I'm going to do return direction is ascending. And then I'm going to do, okay, in that case, I want to get this. Otherwise, I want to get this. Okay, this looks good. So we have the users array sorted by age. Now let's sort it by ID. So if sortBy is ID, in that case, the ID is a string. So I want to compare strings. So I'm going to do similarly as I did above. If direction is ascending, I want to do user1.id.local compare of user2.id. Otherwise, it's going to be in reverse. So user2.id compare. So this local compare function is a function we have on the string prototype, and it's actually used to compare strings, and it gives us a number, and it works very, very well with the sort function on arrays. And I just noticed, sorry, I forgot to put here the arrow. Okay, moving on to the final use case, and I don't even need to put an if here. So If it's not age, if it's not ID, then we're at name. So I'm gonna do the same thing as I did with the ID, but it's gonna be dot name. And let me just, I don't really have like a formatting here, so I'm just gonna have to format it manually. Okay, so now that we have the sorted users, we can actually, let's actually test it that we have done the sort correctly. So I'm gonna return the sorted users, and then I'm gonna say console log getPaginatedData off. Let me just copy all the parameters. So I'm gonna take the users, I'm gonna take the age, I'm gonna take the direction, I'm gonna take perPage, and page number is free. And we get, let's see, should be sorted by age descending. Okay, this looks good. So I have age 41, age 30, and so on. Okay, let's say by ID ascending. So first one is user 1, user 2, user 3. Okay, those are ascending. Let's say by ID descending. Okay, user 5, then user 4, and so on. Okay, this looks good. So I think it's safe to assume this function is, I mean, not the entire function, but the sort logic is correct. Now, what we need is to get the appropriate page. So before I write that code, let's think about it for a second. So let's say I have perPage 5, and I want to get page 10, right? What does this mean? Or actually, let's start with page 1. So page 1 would be index 0 till index 4, right? Which is actually 5 minus 1. Page 2 is going to be index 5 till index 9. Then I can say, okay, page 10, it's going to be actually index, how many we have per page? So 5 times 10 minus 1, which is actually going to be 49, right? Till, no, sorry, without the minus 1. So it's going to be 5 times 10, so it's going to be index 50, till 5 times 10, 5 times 11, right? We go to the next page minus 1. So before the next page starts. And that's going to be index 54. So what I'm trying to do here is actually, and I hope I can manage to get my point across, is to see how we calculate what page we're in. So to get the start of the page, we multiply the per page with the page. And then to get the last index in that page, we multiply this with the page plus 1, and then we remove 1, right? So I can do it like this. Const index of start, actually start index of page, let's call it like this, is going to be per page times page. And then I'm going to say const end index of page is going to be per page times page plus 1 minus 1. And actually I just realized we start the page from page 1. So actually it's going to be, the start index is going to be per page of page minus 1, right? 1 minus 1 is 0, so we start from index 0. And then this one is going to be without this. It's going to be just page. Okay, yeah, this is correct, I think, right? Because again, so page 1 is going to be, start index is going to be 5 times 1 minus 1, which is 0. And the index is going to be 5 times 1 minus 1, which is 4. So that's correct. Okay. Now it complains here because I don't have the variables, but how are they named? Ah, it's called page number. Okay. So page number, and here I have page number. Okay, so now that I have this, the only thing left to do is actually take the values between those two indexes. So I'm going to say return sorted users dot slice, I think. Yeah, so start index of page and then end index of page plus 1, because this is not inclusive, right? So I need to take it up to that index. And looking here, we have ID. So I want to get ID descending, and this is going to be the last page because I have 2 per page, user 1. That's correct. Let's actually take the same parameters I have on the left to verify it's correct. So age, descending, and I should get Luna. Okay, let's say I want page number 1. I should get the users with the biggest age. So that's correct. I get Hendra and Pava. Okay. Now this looks good. And I hope I managed to properly explain this, right? I mean, what I tried here to do is the calculation, how you find the start of the page and the start of and the end of the page. So this looks good. Let's test our solution, and voila, it works. Cheers and see you in the next one.